The ultimate resin printer already exists in 2025, but the problem is it doesn't exist in one machine. So for the last few years I've been reviewing desktop resin 3D printers, and so in this video I'm going to compile all the very best features that I have found and cram them all together into one dream printer. The idea is that 3D printing manufacturers can take a look at this and then get to work on printers so that you or I can print at home cheaply, safely and simply. That's the dream, right? Now I want to kick off this video with arguably the best desktop resin 3D printer on the market right now, Formlabs Form4, because our fantasy printer should look amazing. Clean lines, high quality parts, they're all a given. But let's not forget the fact that it needs to do a job too. An important point is you should be able to see through the hood of any printer that you buy. The Uniformation printers also do this, but other brands like Elegoo or the Saturn 4 Ultra down there have opaque hoods, which means that the only way to look at those models is to physically lift the things up, which adds vibrations and can potentially add some inconsistencies into printing, which we don't want. So let's have a clear hood, please. And yeah, I know the Saturn 4 has a camera, but it doesn't have a light, so it doesn't work in the dark. I mean, come on people. Sticking with the outside, and I hope you agree with me that the lid should be up and over. Lift-off lids are a pain in the arse. And again, the Form4 is a class leader in this, and I'm just going to say three words: soft close hinges. But it could still be better. I would also like to see tighter mechanical hinges so the hood stays in whatever position you put it in. The other thing the lid should do is form a tight seal around the printer to stop any fumes and smells escaping while it's in use. The downside of the lift-over lids though is they take up a lot of space. All of that space above the printer is completely wasted when it's in use. And so here's an idea for you. Why not use a system like the lasers use and have a little roller shutter type lid? It doesn't use any additional space around the printer and you still have good access to the bed itself. And while I'm talking to all you engineers, I'm bound to have missed various bits and pieces in this video and I want to hear your thoughts. What do you think should be included on your dream 3D printer? What features are missing? Because I'm sure manufacturers will look at this video and they'll probably scroll through the comments too. I'll certainly be showing it to several of them once I get the opportunity to do so. So let me know in the comments down below what your dream 3D printer looks like. The other little bits that need to go on the outside of our perfect 3D printer are rubber feet. No one wants a slidey 3D printer, and rubber feet help take some of the vibration away too, which just makes for a more stable print environment. There should also be an extraction port, but it should be a standardized port. I'm thinking 4-inch ducting because it's cheap and it's available everywhere. Any extraction port is better than nothing, but ideally we don't want some bullshit proprietary system that when the printer goes out of production, it just ceases to exist. No thank you. And just to rattle through a few of the features that the printer should have, it should have a power button on the front of the machine please. Ideally a nice tactile one. And a USB port, unlike the Form4, which doesn't have a USB port. Any other inputs, such as Ethernet or the power leads, should be on the back where you can't see them. Keep it nice and tidy. And so now that's done, we can dive a little bit deeper. And I'm going to talk about the screen next. And I'm prepared to die on this hill. The most important parts of 3D printers, in my opinion, are the bits that the people interact with. The stuff you touch. So the power switch is a really good example. The latches and the way the hoods lift up and down is really important. The way you get the plates in and out, same deal. Anything you touch, anything you interact with directly, more effort should be put into those spaces. Because for me at least, that's what gives me the most joy when I'm using different products. And I think this is what makes the Formlabs printer for me one of the best out there, in the fact that everything is just so nice to use. It's a crazy expensive printer, but it is really beautiful. On the other end of the scale, I think that's why the GK2 was so successful too, because it took lots of the functionality from the Form3, lots of the ergonomics and the design cues, and it brought them to the mass market, to an audience that had never seen that functionality before, and all of a sudden they were blown away by how user-friendly the machine was. Car manufacturers do this all the time. The bits you can touch in the car, like the steering wheels and the trims, are all soft leatherette or soft touch plastics. The bits you don't touch very often, like the inside of boots or footwells, hard plastics, much rougher, doesn't matter so much. So if manufacturers look at this video and take only one thing away, it would be invest a little bit of extra budget in the things I interact with directly. Thank you. So back to that screen. Now the screen should be large and easy to interact with. It should feel more like using an iPhone and less like using a calculator. And again, the Form4's version is a really good example of this. There are other brands that do it really well too, like HeyGears. The UI on the Anycubic machine is also very good, but what we don't want are silly tiny screens like you see on the Elegoo Saturn 4 Ultra. They're just really hard to read, and there's no real reason for them to be that small other than some designer thought it looked nice. But at the end of the day, it's so small as to make the user experience harder. I guess the Goldilocks of screen and UI design should be easy to use for someone with almost no experience with 3D printers. It should turn on, be really obvious how to work it, or have guides in it which just show you step by step how to print a printer, or have a step-by-step guide which shows you how to print a model. But it should also go beyond this for more experienced users. What I'm looking for are features like, back to Elegoo, their fantastic RERF functions, which give you full control of calibrating resins and make the whole process much simpler. Although it would be nice if the calibration tests themselves, as in the actual files for themselves, were built into the printer and you could adjust those. And Formlabs also do this cool thing where they put the name of the model onto the base. So it'd be nice if the calibration tests were able to do that somehow. I don't know how, I'm not an engineer, but that would be really cool. So then when you scraped your calibration tests off, you could see which one was which setting. Handy. But it would also be really good to see more advanced readouts too, like the air quality in and outside of the printer, so that you know when it's safe to open the hood, and also how effective your air filtration being, and maybe whether you need to replace the air filtration as well. Machines like the upcoming Athena 2 will have this feature. It would also be really cool to have some sort of way of measuring the UV intensity across the screen. That way you can physically see whether your screen is degrading and whether you need to replace it, instead of just having failed parts and wasted time and effort. In fact, I actually think it'd be really cool if those sensors could sort of compile into some sort of log that you could export, maybe into an app, maybe into a desktop piece of software, and so you could monitor in real time the health of all the components on your printer, and then you can build in replacement times, much in the same way that inkjet printers tell you when they're running out of ink or when they need cleaning. That would be a cool feature. And it's all possible with the sensor technology that we have right now, it's just the software's a little bit lagging behind. And that's obviously in addition to basic functions like moving the Z-arm and exposure tests. I do appreciate that is a lot to ask, but we're talking about a dream machine here, and we're only talking about technology that already exists on other printers, so let's bring it all together, people. Oh, and I want an app as well that basically mirrors the screen in almost every way, but that I can also view my prints remotely on my HD camera, which is inside the printer. In fact, let's talk about the inside of the printer. Let's start with a decent light, so that when you are filming time lapses on your printer with the inbuilt camera, or you're just checking on the quality and the progress of the parts, when it's dark, you can see what's going on. But let's also have the option to turn it on and off when you don't want it. The build plate should be nice and deep, so that the top of it doesn't get covered in resin when it descends into the vat. And much like the ones on the Formlabs machines, they should have a drip capture around the edge to prevent any messy spills. At the end of the day, one of the worst things about resin printing is, frankly, the resin, and the fact that it gets everywhere. And the plate should also have a flex feature, which makes the models really simple to remove. And finally, I think all plates should be fully washable, so that instead of having to clean them down properly, you can just pop them inside a wash and cure, run a cycle, then you let them dry, and the things are clean. There's been a whole spate of plates recently that are hollow inside, so you can't submerge them, and therefore it just makes the whole cleaning process much harder than it needs to be. And while we're talking about resin dripping off, it would also be kind of cool if, instead of having to remove the plate and then hang it on a precarious bracket, if maybe the whole Z-arm could rotate 30 degrees, or maybe it did it automatically. That would be amazing. So the whole Z-arm rotates 30 degrees and at the end of a print cycle, and then just steadily drips off, so that when you come to it, your excess resin's back down in the vat where it should be, and you can just get on with cleaning everything. Kind of like how the Formlabs wash machine automatically lifts prints out of the IPA at the end of a cycle. That sort of automation sounds really simple and sounds really basic, but actually makes a huge difference to how simple the workflow of the printer is. Now, this next one's a little bit controversial, and in fact I've actually been on the fence about it myself, but I think the best design for a resin vat is actually a consumable plastic vat. Bear with me. The worst thing about using resin printers is exposing yourself to lots and lots of toxic resin. It's incredibly harmful, it's bad for your lungs, it's bad for your skin, it's not good stuff. The less you have to interact with it, the better. And if we used consumable plastic vats, what that means is you could have one resin for one plastic vat. When you're done with that resin, instead of having to scrape the vat out and pour it back into its little pot and put it back in the cupboard and then clean everything out and then switch over and pour some new resin in, you just take the plastic vat out, put a lid on it, put it back on the shelf. Get your next plastic vat out, put that one in, put your new resin in, done. That sounds really good, and there's no reason a plastic vat should be that complicated. Or there's no reason plastic vat should be that expensive to buy. Obviously though, the alternative is a metal vat, and metal vats are pretty cool too. If we do have a metal vat though, I would only ask that manufacturers build in decent pour spouts into it, as in a pour spout that projects past the actual vat itself so it becomes easy to pour the resin out. A really good example of that one is the one on the Haygaze Reflex. And while we're talking about vats, we may as well talk about heaters too, because there's a couple of different ways of heating resin 3D printers. Basically, you've either got chamber heaters, either above or below the screen, or you've got heaters that are built into either the vat or just below the screen itself. And the most efficient way to get the heat into the resin is actually to put the heater into the screen itself. You can obviously heat the vat too, but you're obviously going to lose heat that way as well, instead of just up and inside the machine. So the most efficient way, I think, is going to be putting it under the screen itself, much like the Form 4 does. Essentially, if we're wasting less heat, the thing can be more efficient and cheaper to run. But I will say a problem I run into every now and again is, particularly when I'm printing in cold weather, is the build plate itself being quite cold. And so a way to get around that is to either put a small chamber heater in the printer itself, maybe one that only kicks in above a certain temperature, or, another crazy idea, maybe we could have a very small heating element in the build plate itself, which just keeps the build plate at a certain temperature while the printer's in use. That doesn't sound implausible, but I have no idea the engineering implications of that. What do you think? So if you have stuck with me this far, you may like the things I talk about, and you may be interested in 3D printers more generally. I have a newsletter I release once a month which summarises the latest 3D printing news and gives away a free STL file. In this month's newsletter, I'm going to be talking about all the latest releases that were announced at Rapid TCX in Michigan. So make sure you head over to the website and sign up for that. The next section of this video is going to talk about the bits under the hood, as in the bits you can't see when you're using the printer. Some of you may say that this is the most important bit of the printer, and you may well be right. The main point I want to make here is that the materials and components that we want in here should be quality and ideally replaceable whenever that's possible. Specifically, I'm referring to well-engineered linear rails, ball screws or lead screws. I tend to prefer ball screws because they're more accurate and generally last longer, but well-engineered lead screws could work just as well. As long as whatever lift system is used is implemented well, that's all good. It's the same story with the light source. Obviously what we're chasing here is the highest quality UV with an even distribution across the whole screen. It seems to be the best way to deliver that is with a high quality cob light source that's lensed effectively to give even distribution. This is a topic I've been trying to learn about a little bit more recently, but it's quite a big one. I'll try to summarise it here, but if I get it wrong, well, forgive me because I'm not an expert in this field. At least not yet. High quality UV light is all about the transmission of UV light from that light source through the screen, through the FREP, and into the resin itself. And integral to that process is also removing cured resin from the FEP so you can print your next layer. Now I think I want to make a video about this in more detail because this isn't a 2-minute topic. And if that's something you like the sound of, then let me know in the comments below, but the simple version kind of goes like this. To print highly accurate models with decent surface quality and highly rendered details, you need a powerful UV light source. On top of that, you need a high quality precision lens to focus that light source and keep all the light pointing in the same direction so that wherever you shine that light, it ends up exactly where you want it. Once that UV light hits the screen, it needs to then travel through it. Now I'm sure you've seen lots of companies hawking higher and higher resolutions of screen, 8K, 16K, I don't know, 48K, who knows. The thing you need to know about screens though, and why the pixel count doesn't really matter, is that higher numbers mean higher pixel density, but higher pixel density can lead to lower UV transmission. Think of it like this. Each pixel is like a little window that's either open or shut. When they're shut, they don't let any UV light through. And when they're open, they do let UV light through. But each pixel or window has a frame around it, and no light can get through that frame. The more pixels you have, the more frames you have, and so the lower the UV transmission. It's an interesting and slightly counterintuitive problem, and like I say, one I'm not an expert in. So developing a quality screen is all about balancing between UV light transmission, pixel quality, pixel density, all of these various different pieces. And it's why printers like the Form4, which have a 4K screen, can produce miniatures which are a similar quality to much cheaper machines that have, say, 16K screens. But on our dream machine, what we want is the ideal ratio. We want high quality parts with as much detail as we can possibly cram in there, obviously. But the other thing we need to consider is how that screen is engineered so that when we go to print our layer, it pulls away without failing. And again, I think Formlabs have got the best solution on the market right now because it's a mechanical solution, but one that doesn't revolve around moving parts. Essentially what they have is a little wrinkly surface, and that means that that texture causes the FEP to release more easily, and as a result, you can have lighter supports and faster prints. Other brands do this differently, like Elegoo with their tilting vat, or Haygears with their PRM system, but I'm a big fan of simplicity, and the solution that Formlabs have come up with is a good one. So there it is. This is my call out to 3D printer manufacturers. From that previous list, I would like all the parts to be serviced for a long time too, and easily replaceable. But if I could have one final plea to manufacturers of 3D printers, and that is, if you want them accessible to the mainstream public, they've got to be under $1,000. Simple as that. We are so close, but we're not there yet. But I remain excited for the future of 3D printing, and I hope you are too. So all that's left for me to say is a huge thank you to everyone who supports me over on Patreon or chats to me over on Discord. You are absolute legends, and you really help me keep the lights on and keep my spirits up. This has been RisingApe Minis. I've been James, and I'll see you next time.